Hello and welcome back to the Green Ninja Climate Science series. This is the third video in the series. In this video, we're going to be talking about the question, are humans increasing greenhouse gas concentrations? And if so, how big is the human component of increasing greenhouse gas concentrations in the atmosphere? And in this video, we're going to concentrate just on carbon dioxide, which is probably the most famous greenhouse gas, just to kind of keep things more simple. But in the last video, we showed that there are quite a few greenhouse gases in the Earth's atmosphere. But for right now, we'll just focus on CO2. So I'm going to introduce this, well, first of all, by essentially answering the question right away. Are humans increasing greenhouse gases in the atmosphere? Well, yes. But human activities account for just a small percentage of the total carbon dioxide that goes into the atmosphere annually. So this is a true statement, and I just want to contrast this with another true statement, and I think that this will help us, spark some curiosity, and it will help us get a better understanding of what is going on in the true climate system. So this other statement is that while it's true that human activities account for only a small percentage of the CO2 that go into the atmosphere annually, human activities have caused a dramatic spike in atmospheric CO2 concentrations. So by dramatic spike, I mean that CO2 was roughly constant for a few thousand years, and then all of a sudden it has gone up by about 40% in the atmosphere since the Industrial Revolution. And we're expecting it to approximately double from its previous concentrations by the middle of this century. So that is a pretty dramatic spike. So how is it possible that number 2 and number 1 can be true at the same time? So in order to understand this, we need to get a little bit of a better understanding of the Earth's carbon cycle. So the carbon cycle in reality is very complicated. So all life on Earth is carbon-based, so we're constantly taking in carbon and emitting carbon both into the atmosphere and our surrounding environment. And carbon is in rocks and obviously in fossil fuels and all sorts of things. And so this carbon is constantly cycling between different reservoirs. So just at a very, very rudimentary level, we can say that, okay, plants and animals in the land surface give about 60 gigatons of carbon per year into the atmosphere. And prior to the Industrial Revolution, we had a situation where that was approximately balanced by 60 gigatons a year coming back from the atmosphere into plants and animals and the land surface. And then also in the ocean, they have their own carbon fluxes. Approximately 70 gigatons of carbon per year was coming out of the atmosphere and going into the ocean. And approximately 70 gigatons a year was leaving the ocean and going into the atmosphere. So we had carbon moving all over the place, but you can see that the net amount of carbon in the atmosphere should not have been changing, and that is essentially what we did see, that CO2 in the atmosphere was pretty constant prior to the Industrial Revolution, not because the amount of CO2 or the CO2 in the atmosphere was just staying there, but because the amount going in was equal to the amount leaving. So this is just like the family budget analogy that we talked about in the previous videos. So since the Industrial Revolution, however, we have found coal and petroleum and natural gas, which are hydrocarbons. They're carbon. And we've found this additional reservoir of carbon, and we've started mining it and using it to power our societies. And we have increased this new flux of carbon into the atmosphere. So this new flux is only about 7 gigatons of carbon per year. And so 7 gigatons of carbon compared to 60 and 70 is pretty small. So this is actually, only about 5% of the total carbon that goes into the atmosphere any given year. But you can start to see that we've created an imbalance. So it used to be the amount going in was equal to the amount coming out of the atmosphere, but now we've shifted that where there's more coming in than leaving, and so it can kind of follow from that, well, you're going to start accumulating extra carbon in the atmosphere. So to nail this point home, let's use another analogy. So I could have gone back to the family budget analogy, but just to switch it up, let's use a bathtub analogy. So you'll find that this is essentially the same idea as the energy budget, but just in the form of a bathtub now. So let's say that our bathtub is the atmosphere, and the water level in the bathtub is the amount of carbon dioxide, the carbon dioxide concentration in the atmosphere. So we have a certain amount of CO2 going into the atmosphere every year, let's say, or every unit of time, and we have a certain amount coming out of the atmosphere. And so let's just say in this particular situation, if we put some real numbers on it, let's say that we have a gallon a minute of water coming in to the bathtub, and the drain is open. We have a gallon a minute of water leaving the bathtub. So if we have 20 gallons of water in the bathtub, we are not increasing the amount of water in the bathtub over time. So this, since the same amount of water is coming in as is leaving, that means that over 1 hour, 2 hours, 3 hours, you don't change the actual water level in the tub, even though you are cycling water through that system. So the other situation is you can increase the amount of water going into the bathtub by just a couple percent, so in this case 4%, and increase what's leaving by a little bit too, by 1%. But you see that we have this leftover 0.03 gallons per minute that are coming in but not leaving, and so that will be accumulating in the bathtub. So in this case we have 0.03 gallons a minute accumulating, and so if we had 20 gallons in the bathtub, after about 5.5 hours in this totally made up example of using random numbers, the tub would have 30 gallons. So this just illustrates the idea that you can increase the amount going into the bathtub by just a small percentage, but over time all that extra kind of adds up and causes your water level to increase. And so if we increase CO2 going into the atmosphere by just a few percent, and we don't increase what's leaving by as much, then we have some left over, and that accumulates year after year after year. So that's kind of the situation that we have in the real climate system. And we can see that in graphs of carbon dioxide. Here's some other greenhouse gases as well. But just to focus on carbon dioxide, we know from air bubbles trapped in ice cores that CO2 was relatively constant from the year 0 up until the Industrial Revolution. And then it immediately spiked when we started burning fossil fuels that contained carbon and released CO2 as a byproduct. So we put more CO2 in the atmosphere, and although it's a small percent compared to the natural fluxes that go in and out of the atmosphere every year, we still have caused a dramatic rise because what we're putting into the atmosphere is not totally taken out by the natural climate system. So one extra point that I want to look at before we end this video is sometimes you'll hear people make the argument that they don't want controls on CO2 because after all, people exhale CO2. And so if you have any type of law that might regulate CO2, then you could theoretically regulate people's breathing or something like that. So I wanted to address whether or not this is a legitimate concern or not. So we don't really have time to go into the mechanisms behind how carbon leaves the biosphere every year and comes back in, but essentially it's just photosynthesis and respiration. But zooming into this cycle, we see that plants take up carbon from the atmosphere from photosynthesis, and then animals and humans eat the plants and they release carbon to the atmosphere through respiration. But you can see that this is kind of a closed cycle. So this component is not increasing CO2 in the atmosphere. Only this component, where we found additional carbon in underground that was not previously accessible to the atmosphere, and we're putting it into the atmosphere. So that's what's causing carbon to increase, not this component. So you could put, 10 billion people on Earth, 10 additional billion people on Earth, and they're all exhaling CO2. But that CO2 came from the atmosphere to begin with, so it's not actually increasing the amount of CO2 in the atmosphere. So just one more diagram to show that. We have CO2 in the atmosphere. It's taken up by plants and incorporated into their structures, or the carbon is anyway. And then humans eat plants, either directly or they eat animals that ate plants. And so that carbon gets incorporated into the animal's body and then into our body. And then we release that carbon back to the atmosphere in the form of respiration. We breathe out carbon dioxide. But again, this is a closed cycle. We are not increasing the amount of CO2 in the atmosphere from this cycle. The only way we can increase CO2 in the atmosphere currently, or the way that we are doing it currently, is by finding an additional reservoir of carbon and pumping that into the atmosphere at a very fast pace in terms of geological time, and not from breathing. So it doesn't make any sense to say that we should regulate breathing or anything like that, because that's really not a problem at all in terms of how much change we're getting in the Earth's carbon cycle. So that is essentially the answer. Humans are increasing greenhouse gas concentrations. It's a relatively small percentage compared to natural fluxes, but over time it adds up and has caused a big change in the amount of greenhouse gases that are in the atmosphere.